In this video, we'll continue to cover content in Lesson 3.4 and 3.5. Our new vocab will be the word multiplicity, and we'll explore how multiplicity of a factor will affect the behavior and the look of the graph. So we'll start with the definition. Multiplicity is the number of times a factor appears in the factored form of the polynomial. So in Desmos, I have typed up a few polynomials in factored form, and we'll look at these graphs in just a second. But in this first one, we have x minus 1 as a factor and x plus 2 as a factor. Both of those factors have a multiplicity of 1 because they only occur once. Where here, x plus 2 still has a multiplicity of 1. But when we look at the x minus 1 in this second example, x minus 1 and x minus 1, it appears twice in this function, or in the factored form. So we would say the multiplicity of x minus 1 is 2. In this third example, you may not know it, but if you graph both of these, they actually are the same graph, because taking something times itself, even x minus 1, is squaring it. So we can especially see here that the multiplicity is 2 because of that power, but sometimes we'll write it out and sometimes we can write it as that term squared. It's still safe to say that x plus 2 has a multiplicity of 1. Now I'm going to go down here just for time purposes. Each of these x plus 2's, all these powers out here are just 1. It only occurs one time. We don't have to write that power of 1. So every time you see purple, we're going to assume that that's still a multiplicity of 1. The factor x plus 2 occurs only one time, so we'd say that 0 has a multiplicity of 1. Now if we look at this factor, I've upped the ante. We have x minus 1 to the third. There we would say the multiplicity of that 0 is 3. Now do recall that, for example, on x minus 1 is what we call the factor. But the 0 is actually x equals 1. So we could also say that the 0 at 1 has a multiplicity of 3. And that's probably how I would refer to it more, but oftentimes you'll see it written in the factored form. Let's do another one here. If we see x minus 1 to the fourth, we would say that the factor x equals 1 has a multiplicity of 4. And again, this color code goes with that color up there, because that factor occurs 4 times. And as it continues, we won't write these ones in, but this factor in this example, the x minus 1 factor, occurs 5 times, so the multiplicity of that 0 is 5. And here we've upped it a little bit even more. We could go back to our pink, and now my x plus 2 occurs 3 times. So we would say the multiplicity of that is 3 as well. The multiplicity of our 0, negative 2, is also 3. Now that we know what multiplicity means, we want to look at how it affects the graph. What happens to each of these graphs when we type them in Desmos? So they're color-coded again here, but as we look at this first one in red, we notice that it's just a basic parabola. One we've seen before, one we've worked with. X minus 1 and x plus 2, there is where they're crossing at negative 2 and positive 1, because remember, 1 minus 1 is 0, that's why 1 is a 0. And negative 2 is another 0, that's why our 0 is the opposite of that factor. Each of these, pretty standard. We expect it to go down from the positive region into the negative, and then come back up from negative to positive. I would say it drives right through that x-intercept, passes right through normal as we would expect it. Now let's look at the blue graph. So this one looks a little different. We've graphed a lot of parabolas in our day, but now we're looking at a different type of function, kind of a more curvy one. You may recognize that as a cubic, and let's go check how we know that it is. We have an x minus 1 times an x minus 1 times an x plus 2. One thing you might be able to note, in this first problem we had x times x to make x squared. Something I didn't mention on the last slide, but that would be degree was 2 here. Now our degree is 3. That's because if I made us multiply all of these out and got an answer, and then did it again with this x plus 2, I would have an x to the third. So this is one of the looks of a cubic, or an x to the third graph. Again, we sometimes refer to that as a cubic. When I multiply that out, let's look at our zeros now. So my first 0 here is at negative 2, and that is indicated by this x plus 2. My x equals negative 2 is a 0. Right here, my second 0 is at 1, but notice how that appears twice. We would say the multiplicity of the 0, x equals 1, is 2 because it's occurring twice. But also look how that's different than from the first graph. That first graph went straight down and back up right through the x-axis where we expected it to. Now it's driving right through -2, just like it did in the previous example. But now it's bouncing off or having a turnaround point here at x equals 1. Let's keep looking at some patterns and see if that's always the case. Before I move on too quickly, as I slide the green graph in here, not surprisingly, it matches exactly because I mentioned how the second and the third polynomial here in factored form are the same. Remember, x minus 1 squared is the same as x minus 1 times x minus 1. So it's no surprise that this graph is really the same on this green one. But we can review that the multiplicity of this 0 at -2 is 1 because it only occurs one time. And the multiplicity here at 1 of the 0 at x equals 1 is 2 because it occurred twice with the squared or written out separately. Looking at our fourth graph, we see we have x minus 1 still and x plus 2. So nothing new here at x plus 2. At -2, since that's our 0, remember it means our 0 is at -2, it still has a multiplicity of 1, and it's driving right through there. But notice on the x minus 1 now, we went from a multiplicity of 1 to a multiplicity of 2, now it's a multiplicity of 3. It's still crossing the x-axis at 1, and it does power through and get through there, but it creates that little flattened out version there, like a lingering cross through, if you will, a little delayed. So that seems to be happening when when our x equals 1 has a multiplicity of 3. Up in our game again here, we notice the x plus 2, that -2 crosses right through there, the x-axis and the x-intercept, has a multiplicity of 1 and drives right through there. Look what happens now at our 1. When x equals 1, again, we're still hitting the x-axis. That's not changing. Our multiplicity is 4, but now it's even delaying even more. It's flattening out and hitting x equals 1, but definitely flattens out and then turns around. Here our x plus 2, same game, we're crossing here at -2, but now when we look at the x equals 1, so the multiplicity is now 5, but it is still hitting the x-axis, pushing through, going through from negative to positive, and flattening out again a little bit even more than it did when the multiplicity was 3. Something to compare here real quick. The one we were just on when we have the multiplicity of 5 here at 1. See how that flattens out? Notice how when we go back to the multiplicity of 3, okay, so it's up a little bit higher here, it still flattens out, and that's this one, the multiplicity of 3, still flattens out, but just not as long or as much. And then for the big one here, we have got x plus 2, I changed it up a bit, x plus 2 at -2, we have our x equals -2 having a multiplicity of 3 now, and there's that flattening out like we just saw from the purple one when it was at 1. But then we also have at x equals 1, our multiplicity is 2, and there it is doing that touch the x-axis at 1, but turn around and not go from positive to negative. So if you look at all those slides again or play around with them on Desmos yourself, there does tend to be a pattern. And here's what we're finding. When the multiplicity of a 0 is odd, the graph of the function crosses the x-axis. It goes through from positive to negative or negative to positive at that x value. So for example, on this first one, each of these has a multiplicity of 1, which is odd. That's why the graph goes from positive to negative straight through there, or from negative to positive. Do keep in mind, though, that there are some times when the multiplicity is odd, for example on this purple graph. When it was odd and a power of 1 here at -2, it went straight through like we would expect it to, but sometimes it goes from either negative to positive or positive to negative by delaying or flattening out just a bit, but it still does change signs. Now when the multiplicity of the 0 is even, the graph of the function has a turnaround point of like bounces off the x-axis, if you will, at that 0 on the x-axis. So looking at this second graph that was, or the first graph here that was green, we notice that the multiplicity of x minus 1, or the 0 of x equals 1, was 2. There's where it hit. I'm sorry, the multiplicity was 2, but it hit at 1. Okay, so when x equals 1, we had our 0. The multiplicity was 2, and there we see the turnaround. It did touch the x-axis and turn around at that 0. Same thing for when we went to this black graph here. We've got x minus 1 to the 4th. That means at x equals 1, we knew the multiplicity was 4, and that's even, so it's still going to turn around here at 1, have a turnaround point. But the higher the power, kind of the longer it delays, you could say. It's going to bounce off that x equals 1 as a turnaround point, but it's just going to take a little longer than it did, say, when the power was 2. In a quick summary, we could look at that last graph here in red, where we had our multiplicity at 1 being even. Okay, I'm kind of in backwards colors here, but when I have multiplicity being even at 1, it does turn around, okay? When I have the multiplicity of x plus 2, or at negative 2 being odd, it goes through at that x value. Does delay just a tad because it has a power of 3, but it's still odd, so it's going to change signs from negative to positive there. So a quick look at example 2 here. This is from lesson 3.5. They say, how does it affect the graph? Just to summarize, you can see all of these red factors, and eventually zeros, if you will, have odd degree, 1, 1, 1, 1, 1, and 3. Every single one of those red dots has the graph going from positive to negative or negative to positive. It switches zones, if you will, goes through the x-axis. Whereas the even ones, here's a squared on this factor, here's a 4 on this factor, it will bounce off or turn around. Notice how it lingers a little longer here on that turnaround because it's a higher power than 2. But that would be how your graphs behave when the multiplicity of the 0 is even or odd.